Hey, life science classes. I just wanted to let you know I do miss seeing each one of you every morning, seeing your bright, beautiful faces. Hopefully, this will end and we'll at least be able to get back to school for a little bit so that we can once again talk face to face. Expect some Zoom conferences in the future. There will be some changes coming up, but let's go ahead right now and let's start talking about vertebrates. We're going to jump into that and see if we can get this done in the next 14 and a half minutes. All right, we are starting vertebrates. We looked at invertebrates last chapter. Those are organisms that do not have a backbone. They do not have an endoskeleton. They have an exoskeleton. What is an exoskeleton? Very good. It is a skeleton that is on the exterior, on the outside of the animal, giving support in that way. All of the soft tissues will be inside. Exoskeleton would be like, think of a lobster, the hard shell on the lobster, even an insect. That's why when you step on an insect, you get that nice little crunching sound. But those are exoskeletons. Vertebrates we're going to talk about, they all have endoskeletons. Their skeleton is on the inside, whether it's made of bone or cartilage, as we'll talk about today. Let's get into looking at some terms. Today we're looking at, we're just going to talk about the intro to vertebrates. We'll get a few very important terms that you need to know and need to understand so that you understand what it is we're talking about. And we'll look at our first two examples, our first two classes of vertebrates. We'll talk about fish and amphibians. First thing we need to talk about is that we are talking about chordates. Chordates are animals in phylum Chordata. All of these animals, at least at some point in their lives, have a nerve cord and some type of flexible rod in their back that provides support, and they have slits in their throat area at some point during their development. Some of them will remain as aquatic animals, meaning they live in the water, whether we're talking about freshwater or marine, living in the ocean organisms, or we are talking about semi-aquatic animals that spend some time in the water, some time out of the water. Chordates also, phylum Chordata is a large classification because it's so up. If you remember our pyramid, up at the top, you've got your widest group with your kingdom. Then you've got phylum, class, order, so on and so forth. We're at the phylum, so it's still pretty wide. It includes quite a bit of examples of organisms, quite a few different types of organisms. Now, most of these chordates are going to be vertebrates, meaning they will have a backbone. And that backbone is part of a endoskeleton, an internal skeletal system. That endoskeleton will support the body as well as providing protection for internal organs. Now, in providing support, you also have a hard surface, a lever, if you will, that the muscles can attach to allow for movement. And protection of the organisms, think of your rib cage. That protects your internal organs, what we refer to as our vital organs, heart, lungs, liver, that sort of thing, that if those are damaged, it can endanger the life of the organism. So this endoskeleton centers around that backbone, around that vertebral column is another term that will be used in biology. But it centers around that, and the endoskeleton provides support, protection for organs, and gives movement because it gives muscles a place to attach. Now, vertebrates also are classified as either ectothermic or endothermic. An ectotherm is an animal that cannot maintain its own internal heat. It has no way to do that. It must get heat from its environment, whether sunning itself like we see with reptiles. You'll see the iguanas that have taken over South Florida. You'll see them out sunning themselves. You'll see snakes will do that. Other lizards will sit out in the heat and absorb sun. Typically, amphibians and fish will get the temperature from the water or the air around them. Amphibians often will sun themselves as well to maintain heat. Fish don't really sun themselves, but they will maintain their body heat by the water temperature around them. Endothermic animals. An endotherm is an animal whose body regulates its own temperature by controlling it internally. So a bird, a mammal like a gorilla, or your pet, your dog, Fifi, can maintain its own body temperature, whether heating or cooling. Birds and dogs will pant if they're too hot. Humans, we're not animals, but we are endothermic. We maintain our temperature. If you're cold, you shiver. You move around. You produce heat. If you're hot, you sweat to cool that off. So we can maintain our own internal temperature by other means. Let's look at fish. Fish, again, they're ectothermic. They live in water. Their temperature is determined by the water temperature they live in. If you've ever had fish, you know this. When you clean out the tank and replace the water, what is it that you always have to make sure you do? That's right. You've got to make sure that you put the fish in a bag or some other container with the old water in it, and then you can put that, once you replace the water, you can put that bag into the new water and let it slowly change the temperature before you dump the fish in. Once it's in there long enough for the temperature to regulate, then you can dump the fish in. Otherwise, if you don't, the fish will be shocked by the temperature. It will have to change temperatures too quickly, and that can and most likely will kill the fish because they maintain their temperature based upon their environment. Now, fish have fins. That's how they move. They obtain oxygen through gills. Those are structures that pull the oxygen out of the water. They don't breathe air. They essentially breathe water and pull the oxygen out of the water. We pull the oxygen out of the air. There are three types of fish: jawless fish, cartilaginous fish, and bony fish. Jawless fish are just like what it suggests. They don't have a jaw. They don't have a bony jaw. They will have teeth, and they have muscles that they can move those teeth. They don't chew. What they do is, like a lamprey is a parasitic fish. It will bite into the body cavity of a fish, the body of a fish, and use these jaws, use their teeth on their mouth to open up a hole in the fish and suck out its body fluids, its blood and any other fluids that happen to come out. And that's how they live off of it. Jawless fish do have skeletons. Those skeletons are made of cartilage, like we'll see in the cartilaginous fish, like sharks. If you want to know what cartilage is, it's a very soft bone. Think of, if you'll reach up and touch your ear, the top of your ear that's made out of cartilage, you can move that, fold it in half, bend it. That is cartilage. It's a very thin cartilage there, but cartilage is very flexible. It also decomposes very quickly because it is soft tissue. That's why we don't find a whole lot of remains of jawless fish, and we only find certain parts of cartilaginous fish. Let's talk about cartilaginous fish. Cartilaginous fish they do have jaws made of bone. They also have scales. Jawless fish do not have scales, but they have scales. And they have skeletons made of cartilage that makes them very flexible and allows them to move very, very quickly. and they can bend quite well. And because cartilage decomposes very quickly, typically the only remains that we find of cartilaginous fish will be their jaws. So we'll find shark jaws and their teeth. Their teeth are made of bone as well. Those will be rather easier to find in the fossil record. Let's talk about bony fish. That's our last type of fish. They have jaws, scales, and a pocket on each side that holds the gills. They also have hard bones. And you can see here the pocket that holds the gills. These are called, this is called a gill slit. The fish will pull in water either through its mouth. Some of them do have nostrils. They can pull in water through those openings. The water will go over the gills. The gills will pull out the oxygen, and the oxygen will be put into the blood or into the swim bladder. A swim bladder is a gas-filled sac inside the fish. As that fish puts oxygen into that sac, comes out of the blood, goes into that sac. They can inflate or deflate that sac, and that helps them to change their depth. They can tell what depth they're at because if you notice on the fish have this dark line that goes down them. That's called a lateral line. That lateral line is a sensory organ. It's a sensory nerve that allows them to determine where they're at, the depth that they're at, and whether they're right side up or not. And they can change their depth using this swim bladder, and it's literally a air sac inside it. When you dissect a fish, you can find that and pop it. It's kind of funny. But that is how fish will be able to change their depth, by how much air is in that swim bladder. And we got about 2.5 minutes left, so let's talk about amphibians very quickly. Amphibians are ectothermic vertebrates. They spend their early life in the water and adulthood on land. Salamanders, frogs, and toads. Can anybody tell me the difference between a frog and a toad? That's right. A frog is semi-aquatic, spends most of its time in the water, will spend some of its time on land, can be on land. Toads will spend pretty much all of their life on land. You'll find them much farther away from sources of water. Salamanders are typically, you will find them very close to water. Some of them live exclusively in water. They still have gills, and they're usually external gills. Salamanders often will keep those gills even if they're terrestrial. That's why they must remain moist. And usually stay pretty close to water of some sort, so that they can remain moist in order to be able to pull oxygen out of, get oxygen into their body. Amphibians do have lungs, so they can breathe on land. They exchange oxygen and carbon dioxide through their skin, so they can breathe through their skin. Frogs do that. Most of their gas exchange, though, is going to be through their lungs, but that skin, the skin of amphibians, is also used for gas exchange. Now, most amphibians undergo metamorphosis. Metamorphosis simply means changing form. If you've ever seen a tadpole in the water, tadpoles will become frogs through metamorphosis. They'll lose their tail. Their gills will disappear, and they'll develop lungs, and they will also grow legs. It's a somewhat short process, but they will do that. Amphibians also have a 3-chambered heart. They have 2 atria and a ventricle that will pump blood. If you have any questions on this, and I realize I went through it very quickly, but I'm running out of time, please email me. You guys Have a great day, and remember, I love you and love you guys, and can't wait to see y'all